It is 2:05. We're going to call the public permit hearing to order. We have all members present except for Chris Zeig. He is absent today. Item number one, permit hearing on the following operating permit amendment application. One, existing operating permit for Circle X South Cooley LLC. Well number 3, BVOP 0001. Located 2.79 miles northeast of the intersection of Wheel Corner Road and Holly Cemetery Road in Robertson County.
We have no comments. Didn't receive any kind of comment on this is a permit amendment, and we've had no public input on it.
Is anybody from the public wishing to speak on this item today? Hearing none, we'll close the permit hearing. Move to item number 2, discussion and possible action on the following operating permit amendment application. 1, existing operating permit for Circle X South Cooley LLC, well number 3. How?
We have, this is a well that's been in existence before the district came into existence. It was permitted as an agricultural use well, 110 acre feet at a 400 gallons per minute. They come in asking to amend the permit to add commercial and industrial uses to the well, to the permit, to lower the gallons per minute to actual production rate of the well, which is 300 gallons per minute, and increase the total production from the well from a permitted amount from 110 acre feet to 420 acre feet. Go ahead and go to the next one. Have drawn, and so this required, it didn't have to have a footprint before. Now it has to have the footprint because you've done something to the permit. And so it meets all of the spacing requirements. Here's the footprint of the well. They'll use this, have been using it for agriculture in the past, but it's also being used for some of the oil and gas fracking purposes, pulling water out of the pond. There's also, when you get when you're pulling water out of the surface impoundment, you've got to keep those ponds completely full, and via the bed and banks rule from TCEQ, and that's partly what this will also be used for. So it meets all of our requirements, and would recommend that any questions. If you got any questions, certainly fire them at me. If not, I would ask that you approve the permit as presented with the amendments proposed.
Any questions from the board? Hearing none, entertain a motion.
I'll move we approve the amended permit.
Second.
Have a motion and second. All in favor say aye.
Aye.
Any opposed? Motion carries. We will now adjourn the permit hearing and move to our regular board meeting. Call the meeting to order, and we'll have the Pledge of Allegiance.
Jason.
Pledge allegiance
To the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all.
Then we have all board members present except for Chris Zeig. Next, we'll have our public comment on non-agenda items.
We have received no public comments.
Is there anybody from the public here today that would like to speak? Don't want to make up for lost time?
No, not today. I reserve my time for a later day.
How about on agenda items?
We have received no comments.
All right. Anybody from the public wishing to speak? All right, hearing none, we'll move to item number 1, discussion and possible action on the minutes of the March 14th, 2024 permit hearing and regular board meeting.
We had these up online. Everybody's been notified. Hope you've had the opportunity to read through it. If you haven't, then they're very short and succinct and a pretty compact meeting last month. And I'd ask that you approve the minutes as they're presented.
Any questions from the board? Hearing none, entertain a motion.
Move for approval. Second.
Have a motion and a second. All in favor say aye. Any opposed? Motion carries. Before we go on to the next one, I did want to point out that we'll probably go in items 2 and 3 and then skip down to 6 and 7, and then we'll go back into our executive session. That's all right with everybody. Item number 2, financial report for March of 2024.
Okay, we'll start off with the deposits. Total deposits for the month was $75,750.13. Total deposits in March of 2024. On to the balance sheet. There's a total of total current assets at $1,602,656.54. Of that, checking and CDs amount to 1.5 million or 1.6 million. So the vast majority of that is makes up the total assets, then over to liability and equity, and we balance out there, always having the largest amount on this page for the retained earnings, whatever that balances out. Next page in your book is our budget expenditures. So total expenses through March of 2024 is $241,248.37. Our total expenses for that period, $231,219.25. We've used nearly 27%, so we're right on target for what we budgeted for the first quarter and for the year. On to the next page, our collateralization report. Go ahead and move to the next one. So I've tried to make it a little easier to see some of this. Our weighted average maturity date was 107.94 days. Percents of portfolio, 73.5% in CDs, 26.5% in cash. And then as you see at the bottom, the collateralization levels for the two banks, Prosperity Bank's at 130%, South Star Bank's at 139%. Our checks, or I would say these are our expenses, but it's not just checks. It is also, we use a lot of electronic now to stay away from getting checks stolen in the mail. Was $63,900.37. That's from the operating account. And then our total drafts from the Well Assistance Fund was $4,082.50, which was for AGS, hydrogeologic work. And then we had the $30.13 was the deposit on interest on the money. Any questions on any of the financial pages? Not, I'd ask that you approve the financial report as presented.
Any questions from the board? Entertain a motion.
Move approval as presented.
Second.
Have a motion and a second. All in favor say aye.
Aye.
Any opposed? Motion carries. Item number 3, presentation by Mark Nichols updating the board on progress related to the Brazos River Alluvium Aquifer Groundwater Surface Water Interaction Study sponsored by the Brazos Valley GCD and being conducted by Baylor University.
So before Mark gets started, I think y'all seen him before back in January when they were just getting ready to get started. There's been quite a bit of work that's been done, groundwork laid out, a lot of field work, a lot of time spent out in the field. and thought that it would be a good time to get everybody updated on where we are and where we're headed into the summer and fall. So, Mark.
Thank you, Alan. And Dr. Joe couldn't be here today, but he sends his regards, and I'll field any questions throughout the presentation, so feel free to interrupt me if you need to. So I'll start, give an overview. We'll do the purpose and motivation, kind of review it, and then move into the specifics on the study sites and the methods, and then I'll present some of the data that we've collected and discuss the project timeline. The Brazos River alluvium aquifer is important for agriculture, which is why a lot of you all are here today. And current modeling has been limited and has to assume homogeneity and isotropy, kind of just generalizing based off of limitations in terms of data availability. And it's kind of led to ill-defined river interactions in a poorly understood model that we're trying to help alleviate some of. And so that's our goal, is to better define the interactions between the Brazos River and the alluvium that underlies it. And some of the questions that are guiding that is, what's the influence of seasonality, if any, and irrigation, if any, and the long-term impacts of high or low water in the river. And then also discussing and looking at water chemistry that hasn't been kind of looked at, how that changes from the river to the alluvium. So our study site presented here is the middle segment of the Brazos River alluvium, which is what lies in Brazos, Burleson, Milam, and Robertson counties. So this district, as well as Post Oak Savannah district. The alluvium is quaternary in age. It's unconsolidated sediment that ranges from gravel to clay-sized clasts. It's a pretty mixed and heterogeneous aquifer. And so more detailed studies are necessary to really understand how it interacts with the river, how it interacts with the aquifers underneath it. And so that's what we're trying to do. We've identified 3 smaller study sites that we're going to be working at that are numbered here, and I'll go into a little bit more detail on each of those so that we can get a really good controlled look at a couple of different places. At those 3 study sites, the first just north of Calvert, Texas, we're going to coordinate with Aqua Strategies to share for the river data. And then for Hearn and Bryan, we're going to be using the USGS stream gauges that are on the FM 45 bridge and the Highway 21 bridge to get river data that's good and defensible so that we don't have to do that.
Mark, let me interject this. On the number 1, that is up at Bill Vaughn's, out what used to be Tucker, the Anderson property out to the north and west of Calvert. Number 2 is the Holscher property right here out here on 485, on the south side of 485 and adjacent to the river. And then the number 3 is Ms. Sarda, at just on the south side of Highway 21. So that gives you a reference of where those are.
I'll show those in a second. Yeah.
I'm sorry.
No, you're good. And for each of those sites, we're going to deploy temperature level and specific inductance data logger in the well closest to the river. 1 more data logger for water level and temperature. And then there will be a barometer to correct for atmospheric variations in the pressure. We'll collect periodic water samples and isotope samples to do chemical analysis and field measurements, including dissolved oxygen pH and specific inductance. So looking first at the Vaughn property up in Calvert, those are our 3 wells. The left 2 wells, kind of in diagonal, we'll put data loggers in, and that 3rd well will be used to calculate the groundwater flow direction, just with periodic manual measurements. The square that you can kind of see, I don't know if you can see it over on the left side on the river, is where that data logger for the river level is currently deployed for reference. And then the Hearn property, or the Holscher property outside of Hearn, is a similar situation. The green hexagon indicates the USGS river station on FM 45. And then we'll deploy data loggers in the 2 wells that are closest to the river. And the 3rd well that's identified next to the road we'll use for the groundwater flow direction. And then finally, down at Highway 21, where it crosses the river, the red hexagon is roughly where the stream gauge is. And the 3 wells over on Steas Artis Place, with data loggers in the closest and the well by the house. And the 3rd well will be used to triangulate. So briefly going over the methods, I'll talk about a little bit of the historical data science and then the river and groundwater sampling goals. I'll be using data from the Texas Water Development Board's groundwater database, the Brazos Valley and Post Oak Savannah Conservation District databases, and the U.S. Geologic Survey's National Water Service for the river. And I'll take all that data and just briefly clean it. And essentially what that means is pull the latitude and longitude data out of separate files, because the Water Development Board has that published separately. Remove any questionable data, so only use publishable data. Remove any duplicates, reorganize it. And really our goals for this are to have some historical river to aquifer interactions so that we can compare it to what we collect over the next year, as well as to look at historical groundwater flow direction at our 3 sites and historical water chemistry. And so for an example of what that might look like, here is right around the Highway 21 site. It's different wells, but it's the same area. We have historical river levels plotted throughout time, along with historical well levels plotted throughout time. The shaded areas indicate that the river level is above the well level, which would suggest flow into the aquifer from the river, which is kind of the opposite of the standard state, which is on the bottom, where the river is below it, and then the green well, which is well number 33, which is just north of it, and then well 907, which is north of that. So following rainfall, that river comes up, and it should be discharging into the banks, but it's kind of a temporary phenomenon, and it's not very well understood. So that's kind of one of the pieces that's motivating our study, that we want to get a little bit more controlled data and some more frequent monitoring following rain events and following or during drought periods. For the groundwater flow direction, here's an example of what we're going to be doing, hopefully with more points to control. But essentially what this is 3 wells that we sampled in March that show the water elevation. And the furthest north well has a groundwater elevation of 243 feet, the middle one at 236, and the bottom one at 234. Somewhere between that bottom well and the top well on that line is 236, and you can calculate that, and groundwater flows perpendicular to lines of equal elevation, kind of like topograph lines. And so what this is showing is the aquifer discharging into the river pretty clearly. But we want to look at how that changes throughout time. And we're going to be, this is kind of what our goal is for each of the 3 study sites. And lastly, for this part of it, the groundwater chemistry. This is an example of data that we collected in December, circled in red for the Brazos River, plotted against data that was collected by the Texas Water Development Board throughout time for the aquifer. And what this is showing is that chemically, at least with the relative abundance of these constituents is what it shows, kind of percent magnesium versus calcium versus sodium. And then for sulfate, chlorine, and bicarbonate, that the river water is very similar to the aquifer water, which isn't entirely surprising because it was taken during drought, and it should be coming primarily from the aquifer. But we're going to do more work like this to look at the chemistry as well as isotopic chemistry. And so for the river sampling, which we've done one trip, we're going to be getting ready to do another one here in the spring, and then we'll do one in the summer and the fall. We took ionic chemistry, which I'll present in just a second, isotopic chemistry, and then field measurements of temperature, dissolved oxygen, specific conductance, and pH. And then we performed field alkalinity titrations to determine the bicarbonate concentration. And so really what we're trying to do is get a good handle on what the chemistry is of the river. And we're going to do the same thing with the aquifer, and we want to compare them kind of throughout time. We're also going to be doing some physical measurements on the riverbank itself. We're getting ready to do this here in a couple of weeks. We'll be deploying mini piezometers, which kind of a conceptual diagram is over here on the right, where you insert a piezometer, or like you can think of it as a well, but it's really small, into the riverbank. And then if the water level is higher than the river is, it suggests that water is coming from the bank into the river. And if it's lower than the river level is, it suggests the opposite. And so it's an easy thing to do at multiple sites quickly. And it should show whether the water is kind of discharging from the ground into the river or the opposite. And the seepage meter is similar. Essentially, it's a cut-off steel drum that you set in the sediment and then let it sit there for a couple of hours, and you measure whether water went into the bag that's attached to it or came out of it to try to quantify the flow. We also are sampling the groundwater in the wells that I've identified, as well as other ones for water level using sonic, steel tape, and E-line, as well as the same water chemistry as we're doing in the river. And this is a picture from our March trip. The data that we've collected so far is we did one river trip with 7 locations. And like I said, we'll be repeating that this spring, summer, and next fall. And then in March, we sampled 52 well pairs, or 52 wells in pairs for my collaborator Vivian for her study and for my study. And we collected 11 water samples for water quality that we've analyzed. We're still waiting for a little bit of data, but I have some of it. So the river chemistry data that is here, if you have any questions on specifics on that, I can answer them. But I think the most interesting one is that iron, which is kind of like 5 over Fe, is pretty much negligible in all of the river samples that we took. And the reason I think that's interesting is if I move to the next one. The aquifer chemistry, specifically the top 2, the Brazos River alluvium aquifer wells that we sampled, had very appreciable amounts of iron at 6.9 and 1.6 milligrams per liter of iron, which is rather high. And it's, just comparing the aquifer chemistry to the river chemistry, which is interesting. If there's any questions on that. The timeline for this project, starting in the fall of 2023, doing literature review, river sampling and aquifer sampling that we're doing right now. And then moving into the summer, this will be my sole focus, doing more literature review, river sampling, aquifer sampling, and starting some of the data analysis. And then kind of culminating in the end of the fall of 2024 with the final report to y'all in December of 2024. And concluding my portion at Baylor with my master's thesis, as well as revisions in the spring of 2024. And with that, I'd like to thank Alan, as well as Vivian, who's been working with me, Wayne from Baylor, and Dr. Joe Yelderman from Baylor. And with that, I'll take any questions.
Any questions on the board?
I have one.
Yep.
Can you go back to this slide right here?
I can.
Went through that pretty fast. Make sure
Yes.
I understood.
One more. There we go.
On that upper chart.
Yep.
Go through that again now.
Yeah. That's a good question. Yeah. So what it's showing is river elevation, or actually change that well elevation for the green and the red points. And so it's sampled through time. The wells are sampled at each of the kind of dots,
Right.
and then the river is constantly monitored. And so during periods of heavy rainfall, like we're seeing right now, actually, that river level is going to come up higher.
Higher than the well level.
Exactly.
Okay.
Yeah. And so generally, you would expect the river or the aquifer water to be discharging into the river. That's what keeps it flowing during periods of drought, which is kind of what we're seeing in the bottom graph. The standard kind of red on top, then green, then the river. And it's a little bit different on the top half where you're in periods of heavy rainfall where the river's up. We're seeing evidence of the river discharging into the aquifer instead. But there needs to be some more work to really confirm that.
Okay.
I have a question on that.
Yeah.
If rain continues like it's been, and
Yeah.
we don't have drought this summer,
Okay.
and you're done with your study,
Mhm.
any chance that someone would pick that up and continue to see what it's like when it's droughty?
I mean, they certainly can. I don't know if there's any plans to do that. We certainly don't have any plans of doing that because I'll be gone. But that is an avenue if we don't see both heavy rainfall and drought conditions in the next year. That certainly would be an avenue of future research.
Well, hopefully for your sake, it's both, so you can get good data.
I wouldn't complain about a lot of rain though.
No, I'm not. That's what I'm saying.
So most of the time, the water level of the Brazos River is lower than the water level in the wells.
In those wells specifically, and really generally in the wells right next to it, yes.
Okay.
Because there's a kind of the gradient of water discharging from the aquifer into the river. And that's what keeps it flowing, when there's not surface water or surface flow runoff.
What is the depth of the aquifer as far as height of the,
Like from the ground.
Yes.
It ranges up to about 100 feet thick. Kind of water level is generally about 30 feet down. But then the bottom of the aquifer can be up to 100 feet. It's between nothing and 100 feet.
Most of ours, I think, John, are really 65 and closer to from the bottom of the well.
Mhm.
Any other questions? Any other questions from the public?
Which isotopes are you running and what do you hope to learn there?
Yeah, we'll do hydrogen and oxygen. And really, we're just trying to see if there's an appreciable difference between the relative abundance of the hydrogen isotope data and the oxygen. Because surface water should be depleted in the lighter isotopes because it's exposed to the air relative to groundwater. And kind of if you see right in the well closest to the river during the periods of heavy rainfall, that you have kind of more of a river signature than you do an aquifer signature. We're hoping that might help kind of identify that.
Any other questions? Appreciate your report. Thank you.
Thank you, Mark.
We're gonna skip items 4 and 5, moving on to item number 6, general manager's report.
We're starting off with the drought reports, and things look quite good right now. And we hope that it remains that way. I did send this out to you by email this morning, so you got it in an email. The next page is the wells that have been permitted. And totals for each aquifer, always kind of the Bible of what, and a good snapshot of what has happened in the past, what we have permitted, and what's happening now. Just had a well in the Queen City this morning that they gave the permit up. And so that 1843.30 that's on your sheet is now 1703. So one less well, it's become an exempt livestock well. Next page is wells permitted by the general manager. That is 0. We have had none of that so far this year. On to 4C, which is mitigation management, what we've been doing. John I might give you a quick update. He's out in the field today. We've started with rig supply wells that we identified and said, we think these are Simsboro wells. And as John's been out in the field, I've been out there this much, he's been out there that much. Probably have touched close to 125 wells already. And we're having to, because when you're going up 979 towards power plant, and once you get off of where you make the big corner and head back off to the north, those wells in there are right in an area where it can be a Simsboro well, it can be a Calvert Bluff well, much like we've got the issue kind of in the Calvert area. Okay, and sometimes it's kind of looking at a well log, it's kind of difficult to say, well, that's this or that's that. And it all comes down to those water levels and the total at the end of the day, that ASL that we developed, the above sea level. So we're having to do in that area right up in there a lot more. I've instructed John, just go get it, pretty much all of them, so that we can build a baseline and clearly be able to say, that's going to be a Simsboro well, that's going to be a Calvert Bluff well. The more data we develop there, the easier it is to be able to identify when you come up to one of those wells. Want to get all of those done before we get off into knocking on doors, making phone calls. I'll say this, the wells that are up and to the north of, to the north Highway 7 and all the way back up into where the Brazos River Authority has their wells up there, Lake Limestone, those subdivisions along Lake Limestone. Most every domestic well up that way, and there's a goodly number up there, are all Simsboro wells. There's no doubt they're all Simsboro wells. It's going to be one of the things that more difficult or the more detailed that we're gonna have to do is along 979 back to where it corners at 2293 and goes back into Bremond, and that stuff moving back into Bremond. That's just gonna take some time, but making good progress on it. And I'm very tickled at how John goes about, steadily at it. So anyway, that's the report on that for now. Next page. The only thing really to update on GMA 12 or the GMA 12 and that planning process. We still don't have a date. Gary assures me that sometime in May we'll be having a date to have another meeting and actually get off into the planning process for this year. Then I will say, and I'll not go through all of the general all the activities. You certainly can read all that, but one thing that we've been working on right now, has to do with what Mark has gone over. We meaning Brazos Valley, me, we've got Gary in the loop over at Post Oak, and we got Zach Holland in the loop down at Blue Bonnet, is to sometime at the end of 2024, when we've gotten some information, at least preliminary, if not pretty close, is to have a stakeholder meeting that's going to involve farmers, property owners, and invite people from the Brazos River Authority, from Gulf Coast Water Authority, from anybody that's got a stake up and down the river, and actually talk a little bit about the science, but try to get in a room and have conversations about why groundwater is important to people that own it. And I think we'll have I'm pretty excited about doing it. We've already got Billy Howe, Farm Bureau, is going to be on the program. Dr. Joe has agreed to, if his schedule fits, to be able to look at all the science that's been done, studies that have been done, just give a kind of overview of, what's happened in the past, where we are now. So anyway, that's planned for December the 9th, tentatively now, and we'll have it over at the JRG office over where FM 50 and FM 60 meet. And I think I'm looking, we'll continue down that road, and I'll keep you updated on that. So, and then the last document there is, of course, always updating where we are on the management plan, and we slowly move towards meeting all of our objectives. We did do. We finished the late winter monitoring well measurements. We've done about 250 that are monitoring wells. This doesn't even include what John's out there doing today and anything to do with the mitigation wells. This is just the wells in the 8 aquifers that we are constantly trying to measure them 4 times a year, 3 to 4 times, that are identified as monitoring wells. So things have been very busy. Things have slowed a little bit for Megan in she's pretty much got everybody except you've still got 1 7th grade.
We've got 2 7th.
2 7th grade classes left to do. I guess they're both in May, early May.
End of April, beginning of May.
Yeah. So deep breath for Megan, hopefully. So it's been busy, but it's always good to be busy. So any questions from anybody? Comment?
Any questions on the general manager's report? No questions. Moving to item number 7, discussion and possible action or possible future agenda items. Anybody have any items they want to talk about for the future?
Not too far into the distant future, whether it's in May or June, I'll be getting James and Chris to, do a DFC compliance presentation where we'll have all of our measurements in and they'll be able to say, here's where we are, here's what the drawdown has been. But don't know if that'll be May or June.
Hearing none. Go to item number 4, executive session. Texas Government Code 551071 to receive attorney-client privilege information regarding pending transport permit applications for groundwater from the Simsboro Aquifer. This time, the board will go in executive session.
You're limping. Live experiences. Where's that? Okay. Yeah, good.
Well, look at it this way, you just have two things together.
2 things.
You good?
The computer, you're good? Everybody back? Everybody's on? Coming out of executive session, we don't have any action. Item number 5, we're not going to discuss today. Item number 8 is adjournment. A motion for adjournment?
Move for German.
Motion? We are adjourned.